applies here. So to begin with, what is Kubernetes? Even before I go into Kubernetes, first we have to understand what is orchestration. In a very layman's language, if I have to explain to you orchestration, the best thing I can do is show you an important image. Orchestrator, an arranger who writes to orchestrate orchestras. You understand, right? What is orchestra? Music. So here, if I talk about this person is the orchestrator, the person who moves the stick, and based on the stick, the band is going to play the music. The band might have different instruments, and each instrument creates a separate music, and collectively we get some music, some song. That's what is the role of orchestrator. So that orchestrator, we are now talking in context of technology. Now, in Docker, we have learned why containerization. With the advantage of containerization, we are able to create images. And these images, once we place it in the registry, we are able to create containers on different machines without really worrying about the dependencies a lot. Just the operating system has to be taken care of, and the Docker runtime has to be taken care of. And we got the flexibility of distributing our applications quite easily from dev box to the production box. So containerization came into the picture. After containerization, I took you to the journey of microservices architecture, where we began with monolithic architecture, learned about the benefits, but more important, the limitations which monolithic architecture provides to the developer community for building high scale enterprise applications. And then we moved on to microservices based architecture. And that time I said a microservices architecture is a collection of many small services which are developed independently, which are built independently, which are packaged and deployed independently, versioned independently, which are upgraded independently, but still will be able to communicate with each other using some standard protocols. That's how I defined microservices. The idea was simple: break a large application, monolithic block, into many small microservices, small pieces. We develop and we build them. And then we have also discussed the various benefits we are going to get by moving on to microservices architecture. Now we understand pretty well that every application we are going to deal with, and if it is an enterprise scale application, which is supposed to have huge volume of requests to be executed 24/7, cannot afford to have downtime, and so on. These are certain requirements which you will find in each and every application. What are these? Replication of components. See, we are not talking about huge amount of load on our application. Maybe at a time we have got thousands of users coming on our website. Definitely one single machine would not be able to sustain the load. We will have to distribute the load between multiple machines. And the components should not be just deployed in one place. We want the components to be deployed in multiple machines, multiple nodes in a cluster. Basically, we want our components to be replicated more than one in number across different nodes in the cluster, so that we can get high availability, and we should also be able to distribute the load between these components. Okay, now that the components are distributed, we also want to have a centralized load balancer which will actually receive the request and then forward to the different components. So we want load balancing facility for distribution of load between different replicated components. We also want a requirement where we would like to scale our application. If the sudden increase is there in the load, if you find a sudden increase in the load, we want more number of instances of the component to be replicated. And if there is a decrease in the load, we want the number of instances to reduce automatically. Number of instances should increase, number of instances should decrease, and this we want automatic. Basically, we are looking for auto scaling feature for our components. When we want to release different versions of the component, we want rolling updates. Now, what are these rolling updates? Let us say we have got 10 instances of a given component running, which is 1.0 version. Now I come up with 1.1 or let's say 2.0 version. That means I want all my old component instances 1.0 to be replaced with 2.0. Now, how can we do it? Most importantly, we want to do this with zero downtime. The best way to do this is perform a rolling update. Let's say out of 10 instances which are running for old version, we bring down one instance and replace that with a new instance of the same component with new version. Another instance goes down, one more instance comes up. One more instance goes down of old version, one more instance comes up. Like that, we want a rolling update feature where gradually the old versions are replaced with new versions. Our components are spread across a cluster of nodes, maybe 10 nodes, 20 nodes, 100 nodes cluster. Each node is one computer. And each of this component is running some application. Mostly that is nothing but a microservice. And that microservice is producing some log. We want a facility so that we should be able to see the logs of these microservices all at one place. We want log monitoring system. We want health monitoring system. We want a system where if suppose a component probably doesn't perform well or it underperforms, we would like to down that component and replace that with a new version. Replace because it is unhealthy. Kill the old one and bring a new one. So that kind of health check also should be done for the components which we want. We want discovery. See, we know that our components are replicated on different nodes in the cluster. We want a feature where I should be able to reach the component from wherever it is located. The component might be there on machine 1 today for some time, but suddenly it crashed. So it might have moved to machine X. Somewhere it should be updated in such a way that now I should be able to communicate with machine X. We want service discovery. We should be able to figure out where is the component on the network. And definitely the component should be secured. Authentication and authorization. Both the things we want to implement. Important point to be noted is these are common requirements of every application which is of enterprise scale. We need this in each and every application. Let it be e-commerce based application, or let it be some other kind of service which is hosted on internet, which is used by huge number of people, maybe some social media website which is very popular, or some website where the review of various products can be performed by different people for variety of products. That site is common. I mean, you can give any kind of website. We want these features. And what if a developer is asked to implement these things along with the business logic, which is the main need of the application? It's going to be a nightmare. If they have to do everything, it's really going to be very tough. So what is the solution? Delegate it. Let us delegate these routine tasks to somebody else who should be able to perform all these things. And that is where the container orchestration comes into the picture. Container orchestration, music orchestrator, who is taking care of managing the music. Here, the container orchestration is about managing containers. Basically, we can treat a container orchestration as an operating system or as a platform which will help in facilitating all these features for containers. So we are going to have, let us say, a microservices based architecture where everything is a microservice. Every application aspect is developed as a microservice. For every service, we will have a container, a Docker container, and we want these Docker containers life cycle to be managed by the container orchestrator system. Container orchestration automates the deployment, management, scaling, and networking of containers across the cluster. That means entire infrastructure management is now delegated, giving the developers to remain focused on the business logic rather than doing this plumbing job. The entire focus of container orchestration is to manage the life cycle of the container. From the time the container is created, the application in that container is started. The application in the container continues to serve the request. Ensure that it remains healthy. In the event of unhealthy, restarting the container, or on completion of the task, stopping the container, or in the event of container crash, restarting a new container, maybe on same node, or if the container node itself crashes, starting a new container maybe on a different node. More important, managing the state if required is all taken care of by container orchestration. Enterprise that needs to deploy and manage hundreds or thousands of Linux containers. Just imagine. We are talking about a microservices based architecture where everything is a microservice. So every small aspect of the application is going to become microservice. So you'll have a huge quantity of microservices. So all these hundreds and thousands of Linux containers and host can benefit from container orchestration. So we have multiple examples of container orchestration. We have Docker Swarm, which is by Docker, but never it really get into production. It is good for doing some case studies, proof of concept, but Docker Swarm is not that friendly that it should be used for a production kind of workload. Though sometimes in the past people have used it and they're all today migrating to Kubernetes. AWS has something called as ECS, Elastic Container Service. That is also now replaced with Kubernetes. So Kubernetes is a container orchestration tool, a container orchestration system, which is going to manage all our containers in which we have got hosted microservices. Yes, there are other examples also for container orchestration, but nobody can match the features and the popularity which Kubernetes has received. So Kubernetes comes as a specification, and it's an open source specification. This specification has to be implemented on different platforms, and different vendors will do that. If I'm talking about cloud, especially the public cloud, EKS, Elastic Kubernetes Service, is by AWS. Azure Kubernetes Service is by Microsoft. Google Kubernetes extension or something, Google Kubernetes Enterprise, or I don't know what is E, but that GKE by Google. Likewise, OpenShift by Red Hat, very, very popular actually. It's a layer which is built on top of Kubernetes. We have got MicroK8s by Canonical and Minikube, which people use it for development. And we have got the Kubernetes projects which are like implemented on bare metal. You take a network of physical computers and you implement it. That's what is kubeadmin can be doing it. Or you have by K3s Rancher, which is a lightweight distribution for edge devices. Yeah, GKE is basically Google Kubernetes Engine, my correction. So these are all different distributions of Kubernetes which are recognized by the Kubernetes community. They all implement the specifications of Kubernetes on their respective platform. Some are free, some make money on infrastructure, and everybody has their own way of licensing. But what is Kubernetes? Yes, Kubernetes is a container orchestration technology. Whatever orchestration features are needed, all those are provided by Kubernetes. And purely container orchestration. That means only containers can be managed by Kubernetes. If your application doesn't have containerization, it cannot be a candidate in Kubernetes. In short, it can be called as an operating system for microservices based application, where we have got hundreds and thousands of microservices deployed as different containers. They're all managed by Kubernetes, and the beauty is it can be developed on desktop and deployed on servers. You can do your development on Mac, Windows or Linux and build containers which will definitely run on Windows or Linux server. Containers aim for support at extremely diversified variety of workloads. The Kubernetes containers can have different types of applications. Stateless application, which is the favorite of most of the application developers, or it can be even stateful application, something like Elasticsearch or maybe MySQL database or SQL Server database. So these kind of stateful applications or data processing workloads can also be part of Kubernetes cluster. If an application can run in a container, it should be automatically going to be a great candidate to fit in a Kubernetes cluster. So to go into the history, Kubernetes comes from a Greek word helmsman, basically person who steers or ships or boat. Steers a ship or boat, basically piloting a boat or a ship. K8s is the short name. K8 characters and S. K8 characters and S. That's how we give the name K8s. Ubernate is 8. It's a platform. Kubernetes is a platform which manages the entire life cycle of the containerized applications and services, which will ensure predictability, scalability, and high availability, which are the main qualities or characteristics of any enterprise application. Kubernetes by itself is written in Golang, a language by Google. What does it orchestrate? Your compute power. It takes care of managing your memory and processor. It takes care of managing your networking between different containers. And at times, for the state to be retained, persistent state, we have storage also, which can be taken care of by Kubernetes. And if you are using Kubernetes, it becomes extremely easy to deploy, scale, and manage applications. So why Kubernetes? Simple, to solve all these problems. In short, Kubernetes takes care of all these things for us. So if I have history, way back in 2003, I'm talking about 2 decades ago, at Google, when they were just expanding their infrastructure through the search engine, even Google probably did not realize that they would become so popular at that time when they started. They started in a garage and then moved on, and they created now what is only a history. But they wanted something which can scale easily. So the Borg system to manage Google search, they needed a sane way to manage their large scale containerized cluster. Though it was very primitive at that time when compared to what it was today, but that was the stepping stone, starting point of the birth of Kubernetes. Only in 2013, Docker has hit the industry. Containerization is what people started looking at, ensuring that everything is packaged in one place so that it becomes easy to distribute the application and run the application on various computers. 2013, Docker has hit the scene and containerization became a revolution. In 2014, 3 Google engineers decided to build a next generation orchestrator. And this was out of their experience of all these years, 2003 to 2014. And built for the public cloud and open sourced it. Basically, they started building Kubernetes, and then later Microsoft, Red Hat, IBM, and many people joined into the stream. And 2015, there was a foundation, Cloud Native Computing Foundation, which was created by Google, and of course others also became part of it. They became member of the Linux Foundation, and then they started building Kubernetes 1.0. KubeCon, Kubernetes conferences were launched, and it did not turn back after that. It's only growing and growing extremely. Today, if you are coming from a developer background, let it be a .NET developer, let it be a Python developer, Java developer, Golang developer, Node.js developer, you are definitely going to find yourself landing in an application which requires microservices architecture. And at that point of time, you will not have a choice but to adopt Kubernetes. Without Kubernetes, microservices architecture are going to be very difficult to manage. And that is the reason you see everywhere today, there is a huge demand for Kubernetes. And most important thing, there are multiple aspects of Kubernetes. To work with Kubernetes cluster, you don't have to be compulsory a developer. Developer is going to write code, let's say in C# or Java, and then containerized the application. Basically, they are going to build images. And these images, whether the application was written in Java or Python or .NET or any other language, doesn't really matter to me when I want to deploy this in a Kubernetes cluster. That means there are two different aspects. Development is a different aspect where the person is supposed to have knowledge of programming. And then the deployment of application into a Kubernetes cluster where one has to write YAML document, where one has to create pods, deployments, services, that and more all is the other aspect. So first and most important thing you should understand, it is not necessary that if you want to be a Kubernetes administrator, Kubernetes developer, you don't have to be a software programmer. That role and this roles are different. You can actually be a Kubernetes certified administrator, or you can also be a Kubernetes certified application developer. CKAD or CKA are the certification exams which are to support Kubernetes. So what is Kubernetes? Conclusive, it's a container platform, microservices platform, and most important, a platform which is portable on the cloud. What does it mean? Today you might have used AKS with Microsoft for deploying your containers in a Kubernetes cluster. For some reason you decide to quit Microsoft and go into AWS, you should be able to do that with ease. All the efforts which one has put in building an AKS cluster for their application should not get wasted if they move to EKS at later point of time, or maybe GKE at later point of time. So EKS or AKS or GKE are just layer. Kubernetes remains Kubernetes in all the circumstances. They are just a platform. Whether you work with AKS or you work with EKS, things don't change when you're working with Kubernetes objects. And why Kubernetes? See, anybody who is successful, people follow. Decades of experience at Google. Kubernetes is already a success story because Google is using it. And most important, it's not native, it's an open source project. Supports multiple operating systems today, Windows and Linux both. You can have your container orchestration, managing containers of Windows, managing containers of Linux both. Yes, it's one of the fastest growing technology with new features getting added at a regular interval of time. And most important, it has good tooling feature. It is managed by some CLI tools, and at the same time you also provide a dashboard and a REST API through which programmatically we can manage the cluster. So every reason is there why the Kubernetes is supposed to be used for container orchestration. You will not find many reasons, at least I don't even know, for not using Kubernetes or replacing Kubernetes with something else. So if you talk about the important features, simplifies application development. Why? The developer doesn't have to worry about the plumbing job. Their primary focus would be on writing business logic, and all management of cluster of container is delegated. Kubernetes has built-in feature for rolling updates, has feature for discovery of services whenever the containers get located or relocated to a different node in the cluster. Basically, Kubernetes has a DNS system of its own, and every Kubernetes container is given an IP address which will be managed by the DNS in the same cluster. You have got provisioning for storage. Basically, you can mount something like Azure storage or maybe a AWS bucket, storage bucket, or a disk can be managed for managing the persistent storage. You have built-in load balancing and scaling capabilities in Kubernetes for distribution of load. You have self-healing for high availability. Whenever the container fails, that container might have died, but in its place a new will come up automatically. And extraordinary support for DevOps. Containers can be easily deployed via a DevOps, maybe Jenkins, or maybe you can use Azure DevOps or AWS DevOps. Any DevOps, if you take, yes, you can easily build a CI/CD pipeline for deploying Kubernetes applications into the respective cluster. So this is how Kubernetes is popular. Feel free to post your questions in the chat, guys. I would pick it up, like in your Azure DevOps expert course, which one would you be taught? We are not going to teach AKS, EKS or any cluster in Azure DevOps. In Azure DevOps course, we only teach how to deploy into the cluster. And we have a Kubernetes course. The Kubernetes course which we teach is very generic, whether it is EKS or AKS or CKE, in GKE, in all places you can make sure that the commands which we use in our course can be used for deployment of the application. It's not going to be different. If you move from AKS to EKS, your learning curve will not be absolutely different. Maybe 2%, 3% might change, but rest of it will all remain same. So feel free to post your questions as and when I get a chance. I'll pick up from the chat and keep answering it. Very important point there. Docker is going to die in future. No. Kubernetes complements Docker. Kubernetes does not replace Docker. Kubernetes needs containerization, and the containerization runtime, which is used in most of the Kubernetes clusters even today, is Docker. Though Docker is no more an official recommendation by the Kubernetes community, but most of the implementations even use Docker only today also. For example, all these EKS, AKS, GKE, all these use Docker. Here also we have Docker support. Minikube uses Docker. So it's up to you whether you want to replace Docker and put something else in its place, but most of the time it is still Docker. So Docker will not be killed or will not die because Kubernetes, it's a complementing thing. Kubernetes, as long as it stays, Docker will stay. Keep that point in mind. Guys, feel free to put your comments as you are listening to the session. The comments can be about the delivery, any recommendations for further improvement. Comments can be about what topics you may want to hear in future. Whenever I get a chance to conduct these kind of webinars, to get the notification, don't forget to join the subscribe to the channel or hit that bell icon. Don't forget to do that. You'll also see on our channel a lot of videos on Azure. Now let's get into the main topic. Kubernetes architecture. See, if one has to build a Kubernetes cluster, there will be one master node and there will be multiple worker nodes. You'll have a master node and you'll have a worker node. Master node is going to contain all managerial components. Basically, master node is the one which will have components which are like decision makers, global decision makers. They are the one who are responsible for scheduling, detecting and responding. All the three important activities. Scheduling, detecting and responding. are all taken care of by the master node. So here you see this is one master node. Entire cluster would have most of the time only one master node, which is mostly called as primary master node. And for the sake of high availability, we might have a replicated secondary master node. But only the primary is active at any point of time. And the primary, when it goes down, then the secondary comes into the picture. So master node is a set of important components which are like, as I said, scheduling, detecting and responding, has API server at its core, and then we have got scheduler, controller and etcd as additional components. kubectl is a utility which can be used by administrators, developers, DevOps engineers, a CLI, command line interface utility, which is going to provide instructions to the API server in the master node for management of the cluster. If I want to create a new pod, I want to create a new service, I want to create a new deployment, I want to update a pod, delete a service, update a service, change the version of the deployment, everything is going to be instructed either by using kubectl, and the instructions are always sent to API server, or by using a web UI dashboard. Through this web UI dashboard also we will send instructions to API server. API server is responsible for exposing some RESTful endpoints. Basically, it is capable of receiving HTTP request, wherein in the request the data will be in JSON format, process the request and generate the HTTP response again with JSON response, the data in JSON format. So API server has a list of endpoints for different operations to be performed in context of different objects. And API server is the only way one can send a request to a cluster, whether it is using kubectl or whether it is using web UI, or even if you want to write your own C# and Java or Python code and directly send HTTP REST API request, then also you'll send it to only API server. API server is the point of contact, single point of contact with outside world for management of the cluster. So it's a front end used by users, client, tools and libraries of Kubernetes. It exposes REST API for health checking of other servers, allocation of pods to the available nodes, in short, container orchestrated communication. What is etcd? etcd is a database. A database, a central store where the entire information about the cluster state is going to be saved. What are the different Kubernetes objects which are existing at a given instance of time? What are the values for different properties of those objects? What is the current value? What is the desired value? All this information is going to be there in etcd. So it's a shared configuration. Whatever configuration data is there in etcd will be shared by the entire cluster. A key value store that can be distributed among multiple nodes. Why would you distribute among multiple nodes? For high availability. In the event of one goes down, we want it to become available from another node because entire state is here. If this disk crashed, it shouldn't happen as if the cluster has entirely crashed. We should be able to be recovered, and for that we need to have replication of etcd. It stores the configuration of Kubernetes cluster and information about the various Kubernetes objects like pods, services, and so on. It stores the actual state and also the desired state. In short, it's a database managing the entire state of the cluster. Then we have got scheduler. What is this scheduler? Another very important component which will be used by API server to decide on which node should the load be forwarded to. In the sense, if a kubectl gives a request to create a pod, API server will talk to scheduler, and from there it will get the information of going to this node or some other node for creation of the pod instance. And how does it work? In each and every worker node, we have got something called as cAdvisor. cAdvisor is a component in the worker node. It works like an agent and it provides information on resource usage and performance characteristics of running container. Basically, it will capture how much memory is available and how much is used, how much processor is available, how much is used on each and every node, and it will report that information to the scheduler. So scheduler will keep receiving updates about the memory and processor availability of each and every worker node in the cluster by way of cAdvisor. And then we have got control. Basically, this is the one which will take care of detecting and responding. Scheduling is done by scheduler. Detecting and responding is done by controller. What kind of detecting? What kind of responding? Suppose we have got pods created in the cluster. Pod is the place where the container will be created, and we know that inside the container we are going to have our application workload, the microservice. What if the pod got destroyed? Or what if the entire node got destroyed? Or what if the current state was 5 instances of the pod, we now need 10 instances of the pod? These kind of detections are all observed by controller. So controller has something called as controller manager, which is nothing but a loop. Controller manager is a loop that watches the shared state of the cluster through API server and talks to, of course, etcd, and manages the attempt to move the state from current state to desired state. For example, current state will be 5 instances of the pod. Desired state is 10 instances. So 5 new pods have to be created. That observation is done by controller and communicated to API server. Likewise, you might have an entire node crash. Node has gone down. So all the pods which are there on that node before it crashed have to be now created on other nodes in the cluster, because we want to maintain that kind of instance count. So that is again taken care of by the controller called as node controller. Then there is something called as service and pods. We never talk to the pods directly. Every time we want to talk to the pod, we'll have to go via service. That means there has to be something which is going to connect the service and the pod, and that's what is the endpoint in the service. Service has endpoints, and there can be more than one endpoint. representing each pod which is behind the service. So if suppose the pod is destroyed, its IP address is gone, and the new pod comes up, it will have new IP address. The endpoint of new IP address should be connected to the service, and that's what is done by endpoint controller. Maybe a little advanced to understand everything at this point of time, but yes, the job of the controller manager here is to ensure that the cluster always remains in the correct state. If there is a difference between the current state and the desired state, it's the job of the controller to initiate the process of moving from current state to the desired state. It's the controller which is supposed to do that. So these are 4 most important components which are part of master node. They're working together. Very important thing. What happens if the master node in the cluster crashes? For some time the master node has crashed. That machine has crashed. Will my application running in the entire cluster stop working? No. A big no. Even if the master node crashes, we will have the worker nodes still running. And where is the actual functionality in these containers? Temporarily, management of worker node will not happen. If the particular pod is destroyed, something else may not be created. But we might not lose the management. We will not lose the containers. Containers will still be there. Of course, if the container crashes, we will not have a new container in its place. Definitely yes. When the main master node crash, primary master node, secondary master node will take over. But the time between secondary doing a failover, when the primary fails, that time what happens to the workload? Nothing will happen. They'll continue to run. That's the beauty of the entire Kubernetes cluster. So what is the role of this kubeproxy, kubelet, Docker? You can see these are all worker nodes. You see there is only one line which connects the master node and the worker node. That is the line from API server to kubelet. So kubelet actually is the main point of contact. Kubelet is a component in worker node and is responsible for entire communication with the API server in the master node. API server, if it has to give instruction to the worker, it will give it to the kubelet. And kubelet, if it wants some information from the master node, it will also talk to only API server and two-way communication. Whenever a kubectl sends a YAML document, YAML document, for creation of, let's say, a new pod, it will actually send it to API server. API server will go to scheduler and take information about which node it should talk to. And now API server will send the YAML, entire YAML as it is to the kubelet. That YAML is nothing but a pod descriptor. And that pod descriptor will have something called as pod spec. And in that pod spec, we will have the reference of the image which is supposed to be used for creation of these containers inside the pod. So kubelet, with the help of Docker, assuming that Docker runtime is used, is responsible for creating these pods. So container runtime on each node in the component that runs the container defined in the worker load submitted to the cluster. Basically Docker. It can be anything equivalent of Docker. Container D or CRIO, anything is okay. They have to be in compliance with Kubernetes CRI, Container Runtime Initiative. Then there is something called as Kubernetes proxy. This is a proxy service which runs on each node. Kubernetes proxy is a service which runs on each node, and any request for a functionality which is actually hosted inside the container as an application, and that too inside the pod, has to go to kubeproxy. Kubeproxy. It's a proxy service. That means it represents the actual service. Our request has to go to kubeproxy. Kubeproxy will forward it to the main service. And of course, the kubeproxy is going to run on each and every node in the cluster. And once it is received by kubeproxy, it will get forwarded to the actual proxy, actual service. And from the service, it will then go to the pod. So kubeproxy is also responsible for implementing network policies. If a request comes from this point and it has to go to this point, should it be allowed or not allowed? This kind of policies can be created, and those policies are managed by kubeproxy. So these are all 4 different components. I already discussed about cAdvisor, which is an agent which is running on each and every node in the cluster and is responsible for aggregating the processor and the memory which is available on that cluster, used by different pods or their respective containers, and reporting that information to the scheduler. So 4 important components are part of Kubernetes worker component: kubelet, Docker runtime, container runtime you can call it, kubeproxy, and of course cAdvisor. Not listed in the diagram, but yes, cAdvisor is also an important part because of which the scheduler is working. So this is what is orchestration. Why it is called as orchestration? Management. You see how the request should go to API server. API server will mark that as a state in etcd. Immediately whatever it receives, it will store it in the etcd. Etcd can later be used by the controller to see if there is a change in state, desired state to current state. Scheduler is the one which will be used by the API server to get information on which node it should submit the request for managing. So all these things are working in coordination. And the beauty is we don't do all these things. The cluster has already been created which is doing these things for us. So what is our role? Our role is going to be primarily managing the containers which has the actual microservice based application. So this is how the entire architecture of Kubernetes is. So basically we have learned in today's session what is container orchestration, what are the features which we want to manage through container orchestration, what are the different certified distributions of Kubernetes, which is an open source specification, understood more about Kubernetes, what is Kubernetes, the history, why do we need Kubernetes today, the important features or characteristics which Kubernetes provides, and we have seen the importance of the master node and the worker node. Guys, this entire course in detail, if somebody is willing to learn, is available on our website. You have got Kubernetes by me and also by Rahul. 2 versions are available. If you are enrolling for the course, you will get access to both. The content is same. The delivery is different. He has got its own way of delivering. I have my own ways of delivering. So I have my Docker and Kubernetes course. He also has Docker and Kubernetes course compiled. If at all you plan to learn Docker and Kubernetes with us, yes, this can be definitely one of the world's best material in the simplest possible language. These courses are also part of our packages if you are willing to learn something like Microsoft Azure DevOps Expert Plus. DevOps Expert Plus also has Kubernetes, Helm, Docker, if you are willing to learn along with us Azure DevOps and Azure Administration. You'll get access to the entire video kit. You'll also get access to the live training which we provide, the information about which will be available here. In case we are taking any kind of live training, for example, we have got 104, Docker Kubernetes, DevOps, all these scheduled in the upcoming month, in the current month actually. There will be batches taken by me also on various courses. You will get to know the webinars which are hosted here. Like today's webinar is this. Next upcoming will be Python. After that, Azure Admin. These are all different webinars which you can actually register yourself for. And our team will send you the reminder on the day of the session. It becomes convenient for you to join. So explore, there are a lot of courses. We have got something called as gold membership, which is like big time value for money. You get access to the entire catalog and the live trainings provided by Microsoft. Entire catalog access you will get. You also can visit our website azure-a2z.com. It has some exam dumps, interview questions, information about certifications in Azure and so on. You can, a lot of information is here. Also, if you are interested in writing AZ900 certification, there is a very good package which we have introduced just for ₹2,000. You are going to get multiple things. Contact my team and they should be able to provide you. You get access to the videos, you get access to the voucher, which is itself worth around almost 4,500 or something. You get access to the question bank. If you want some guidance, you can connect with me. So multiple benefits you are going to get in the context of AZ900 if you want to start your cloud journey. Just for ₹2,000, the entire kit will be given to you. I'm not even sure if the deal is still open or not. Please connect with the team in the backend and they should be able to provide you available. The latest version is available here. So this is all about Kubernetes. I wanted to also take part 2 of it, but some other time I'll do it. Time constraint, we are already about time. There is part 2 of the architecture which I would like to take, where I want to discuss about various Kubernetes objects, and we'll try to do it in the very soon upcoming session whenever I get a chance. Whenever I find my calendar available, I will get online and try to deliver the content. The certification CKAD, Kubernetes Certified Application Developer, entire syllabus will be covered, and some relevant material also I'll try to share with you if you're part of the training. I think there is a Docker Kubernetes batch scheduled very soon. If you want, you can get into it. This course. So this is all from my side. I don't see a lot of questions, so I may probably end the course here. I did share my phone number and my email ID at the beginning of the session. You might see this entire session stored as an archived video on our channel. You can watch at any later point of time and give me the feedback. Feel free to share this link with your colleagues, maybe on LinkedIn. If you are happy about the content, do make me popular. Put it on LinkedIn, tag me. I'm also there on LinkedIn. You can tag me by pasting this particular content on LinkedIn, and I'm pretty sure a lot of people like you can benefit out of this content. I try to always deliver my content in very basic language. I keep the language simple, easy to understand, and I go deep dive into the content also at the same time. Thank you and best of